Okie dokie. Let's do this test review. It is in fact a review, even though it said test and I wrote review, it's really the review. So let's go ahead and work out number one, which I think is the hardest question probably on the whole thing. What you're given is the zeros, which means x equals 5 and x equals 3, or x equals 3. If I set it equal to 0, that means x minus 5 equals 0, or x minus 3 equals 0. And then I'm going to multiply x minus 5 times x minus 3. If I do the box method, I have x minus 3, x minus 5. I multiply and I get x squared minus 3x minus 5x plus 15. So I end up with x squared minus 8x plus 15. That is not vertex form. That is standard form. To change it to vertex form, you have to complete the square. So what I do is I set this equal to 0. I move my 15 over to the other side by subtracting 15 from both sides. I'm going to rewrite it kind of here in the middle. So what I have is x squared minus 8x, and then I'm going to put something here, equals negative 15. So I'm trying to add something to my equation to make it a perfect square trinomial. If I know that it's minus 8x, I take half of 8, which is 4, and I square it, which means I'm going to have plus 16. So I add plus 16 to both sides. I end up with x squared minus 8x plus 16 is equal to x minus 4 times x minus 4. And that's equal to 1. So I'm going to write it as x minus 4 squared. I bring my 1 back over, and that's my vertex form equation. If you're not sure how to do that, you need to go back to the practice problems we did before spring break. But the answer is going to be x minus 4, the whole thing squared, minus 1. Okay, so if you take, and I would do these in my calculator if I were you. I would totally do them and see if it makes sense. Okay, because I think that if I have this function, if I'm going to reflect it, that means that my value in front of my x squared is negative. So the first thing I'm going to do is I'm going to add a negative 1 here to be multiplied times my x squared. And then translating it up means this goes up 5. It doesn't go to 5, it goes up 5. So I should end up with y equals negative x squared. Negative 1 plus 5 is plus 4. And I would probably put that in my calculator and make sure that it looks like it's reflected and moved up. So let's go to y equals x squared plus 1. And then in y2, I'm going to put negative x squared, negative 1, x squared plus 4. I'm going to do zoom 6. Okay, I flipped it over. And I did that wrong, right? It should be plus 6. See, I'm so glad I did that because this one only went up 3, and it should have gone up 5, which means it should have been 6. Let's look at that and see if that looks better. Okay, so now it's reversed and it went up 1, 2, 3, 4, 5. Oh my gosh, I'm so glad I checked that on my calculator because it's not +4, because it's not -1, it's +1. And this is +6. Oh, I'm so glad I checked. Okay. Boy, those calculators come in handy. Number 3, we're doing the quadratic regression. Going back to my calculator, I'm going to go to my y equals. I'm going to clear this out. My plot 1 is not on, so I'm going to turn on my plot 1 by hitting enter. Okay, I'm going to go to stat, edit. I clear out my list by going up to the top, clear, enter. Clear, enter. My L1 values are 5, 8, 11, 13. Oh, made a mistake there, didn't I? 8, enter. 11, enter. 13, enter. 19, enter. 21, enter. 25, 27, 30. My Y values are 30, 22, 21, 19, 21, 22. Uh-oh, what'd I do? 30, 22, 21, 19, 15. Man, I'm bad at this. 19, 21, 22, 30. All right, I'm going to do zoom 9, which should put them in my table, my graph. They look so nicely quadratic mostly. I'm going to go to stat, calc 5. I'm going to go down to store vars, y vars, enter, enter, calculate. And I'm going to write down 0.08 x squared minus 2.88 x plus 41.76. And then I'm going to look at my graph just to make sure I didn't totally mess something up somewhere. It looks pretty good, like a good fit. So I'm going to go back to my paper. I'm going to write y equals 0.08 x squared minus 2.88x plus 41.76. Okay. I noticed when I was checking 8.10 that some people were having a problem finding all the different things that were transformed. So when you're doing problems like this, make sure you look and see if it's stretched or compressed, left or right, up or down, because all those, and reflected. All those things need to be mentioned. If you just mention 1 or 2, you're not going to get it right. So if I'm compressing, that means my parabola is getting wider. And if I wanted to check it on my calculator, I would. I'm not going to, but you should put this in Y1 and then put this in Y2 and make sure it's doing what you think it's supposed to do. Vertically compressed is putting a brick on my head. I'm going to get shorter and wider. So I'm going to put a fraction because that's what makes it get wider. So I'm going to put in g of x equals 1/3 x squared, which is the same as 1/3 f of x. Remember, we used that notation before. If I'm translating it to the left, that's when I have to put it in parentheses. So I need to have my x in parentheses plus 3, because if I want to go left, I put a plus or a minus negative. And then I put the square on the outside. And then I'm going to go to my calculator, put that into Y2, make sure it actually moved to the left like I think it does. Okay, so the next one is reflected and stretched. So to reflect it, I'm going to put a negative. Stretching means I need a number bigger than 1. and then I have x squared. Then I'm going to go to my calculator, put that in y2, make sure it actually does what I think it did. Last one. Okay, I'm changing my vertex. I'm going to use vertex form because I know where the vertex goes. The vertex for the parent function is 0, 0. So I'm starting at 0, 0, which means all I have to do is change where my vertex is. So I'm going to do x minus 2 squared, that's my x, minus 3. And then I'm going to put that in my calculator. I'm going to check where the vertex is. I'm going to make sure I did it right. I expect you guys to do that, and I expect you to use your calculator for every single one of these on your test, because there's no reason not to. Number 5, I had some people who y'all were leaving these as fractions, and you're making your life so much harder, especially when your answer choices aren't fractions. If I know that x equals 2/3, the first thing I'm going to do is I'm going to multiply both sides by 3, as I set it equal to 0, and I have 3x equals 2. Then I'm going to subtract 2 from both sides, and I end up with 3x minus 2 equals 0. That is the same as x minus 2/3 equals 0. It's the same thing, but this is going to give you the right answer. This is going to leave you with extra work to do at the end. So go ahead and solve for set x equal to 0 and get rid of your fractions. If I have x equals -3/2, to set it equal to 0, I'm multiplying both by 2. So I have 2x equals -3. I'm going to add 3 to both sides. I end up with 2x plus 3 equals 0. Now I'm going to multiply this and this together. So I'm going to end up with 3x minus 2 times 2x plus 3. So I know right now I'm going to have 6x squared. And I'm going to have minus 6. So I know my answer. I don't really need to work it all the way out, but I can if I'm doing what I'm supposed to be doing. Blah. Okay. Number 6 is a little tricky because it's really tempting to just say, oh, if I make x squared negative, it just flips the graph over. But it doesn't because it's not in vertex form. Oh, and because I changed it to a fraction. Okay, and it's not in vertex form. So let's go to our graph. And let's turn off the plot. And let's clear out y equals. And let's start out with what we started with is x squared plus 8x. Oops, wrong thing. Plus 8x minus 4. If I just put a fraction, a negative fraction in front of the x squared. So let's put -1/2 plus 8x minus 4. Let's see what happens to our graph. Well, I need to do zoom 6. They're not the same graph though. Zoom 9, wrong. Zoom 6. Okay, there's my first graph. There's my second graph. Let's zoom 3. There's my first graph. Did I do them in the wrong order? I think I did them in the wrong order. Let's look again. Okay. So yeah, my first one is blue. And my second one is red. So my first one is a smile. My second one is a frown. So what happened to my graph? It looks to me like it got wider, which would we expect from the fraction. It flipped over, but it also, the intercept changed. So oh no, it didn't. The x-intercept changed, the y-intercept did not, because my y-intercept is still really close to 0, 0. Just for fun, let's put 0 in. Second, trace 5, enter, enter, enter. Okay, that's going to show me where they intersect each other, which is not what I want. So let's do second, trace 5. Let's see which line it's on. Okay, blue line, black line. Yeah, I don't want that one. All right, trust me, they have the same y-intercept. Now it's going to bug me though. Sure. 0.472136 0. You know, this is just for myself, so you can skip this part. Okay, I want it to be on the red one. Enter. Black one. Go. It's actually not exactly, but it's pretty darn close. All right. So there will not be a question that's hard on your test, but I would say A, although B, it's hard to tell because it's like so close. The y-intercept is so close. I would take either A or B, but technically A is the right answer. All right, moving on. Spent too much time on that. Okay, so we're doing vertex form. We're doing this y equals a x minus h plus k. Our h and k are x and y, so we're actually solving for a. So we have 8 equals a times 1 minus the negative 1 squared minus 4. 1 plus 1 is 2, squared is 4. So I have 8 equals 4a minus 4. I add, oops, sorry, I didn't mean to do that. I add 4 to both sides, and I end up with 4a equals 12. I divide by 4. I end up with a equals 3. So my a is 3. So my formula is y equals 3 times x plus 1 squared minus 4. So there's my equation. Okay, if I were doing number 8, I would put it in my calculator. Oh no, I'm not going to put that in my calculator. Or am I kidding? I could put it in my calculator and find the vertex, but I don't need to because here's my h and here's my k. And what's most important is if it's positive, that means this is negative and negative. So there's my vertex. I'm so used to like yelling at y'all to use your calculator, I forgot I can actually do that. Okay, I would graph these two right here to find out which ones are true. This is my first one where you can put a big old frowny face because the answer is really not there. I know, I hate it when I do that. I made a mistake. These are actually the ones that are correct. So you actually need answer choice E, which is 2 and 3. Oops, let's try that again. 2 and 3, which is correct. And I would graph them and prove to myself that that is indeed correct. And I'm going to be so mad at y'all if y'all... Okay, you might have noticed that number 10 is just like number 1. Except you can leave it in standard form. So if you go back to number 1, you're doing x minus 5 times x minus 3. which is x squared minus 8x plus 15. Oh, wow. Okay, there you go. So let's look at this one. Here we go again. Number 11, guess what I would do? I would graph it because this one also is wrong. Second frowny face. I think those are my only two frowny faces. So we need answer choice E, and you tell me what it needs to be. No, really. You tell me. You tell me what it needs to be. The vertex for this first one is -9, 2. And the second one is -5, -2. So my x value goes from -9 to -5. So it's going to the right 4. So it's either, well, it's not either one of those, is it? And then to go from +2 to -2, you're going down 4, and then right 4. So once again, not paying attention. Okay, number 12. Put it in your calculator. Negative. I didn't want to do that. Equals -0.01 x squared plus 1.06 x plus 0.24. Clear, clear, clear. I don't even need to turn my plot on, but I will. Stat, edit, clear, enter, clear, enter. 7, 20, 33, 47, 60, 67, 8, 15, 24, 26, 24, 21. Zoom 9 surely is a quadratic. Stat calc 5. Bars, y bars, enter, 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 enter. There's the equation I wrote down, -0.01 x squared plus 1.06 plus 0.24. There's my beautiful graph that looks just like mostly the data. All is good. Number 13, use your calculator. In case you didn't know, the points that you see are not your vertex. Just saying. Go to your graph. X squared minus 12x plus 28. Zoom 6. What is the vertex? Second, trace. It's a minimum 3. Okay, I need to find my left bound, and I don't know where my little blinky thing is. Oh, there it is. Okay, it's on the left side of my vertex. I need it to go to the right side of my vertex. Does not matter how far. Hit enter for guess. 6, -8. So it's answer choice E. No reason to get that wrong. All right, standard form. X plus 4, x minus 4. Actually, it's the other way around, but it all comes out the same. X squared minus 16. 15. You know the vertex is, okay, first of all, it's a smile. It's not B or C. Second of all, it's at 3, 1. So it has to be, the vertex has to be that one. Boom. I don't even need to write anything down for that one. All right, 16. Dun, da, da, last page. Okay, so we're writing the equation. For this one, I used my zeros because there's not really reason to worry about my vertex because it's standard form. I don't know why it does that sometimes. Okay, so I have x equals -3, x equals 5, x plus 3 equals 0, x minus 5 equals 0, x plus 3 times x minus 5, x times x minus 5 plus 3 times x minus 5, x squared minus 5x plus 3x minus 15. Wow, we did this before. There we go. X squared minus 2x minus 15 equal y equals. Okay, 17. Put it in the calculator. When it hits the water, that's going to be a root. My chair is squeaking. It's kind of bugging me. Okay, we're going to put in negative 16 x squared plus 8t plus 8x plus 48 zoom 6. Actually, I don't need a zoom 6 because I'm looking for this point right there where it crosses. So I need to go back to my y equals. I need to put in y equals 0. Go back to my graph. Second, trace 5. I don't know where my blinky thing is. Oh, it's way up at the top. There it is. Okay. Enter. 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 2, 0. That means my diver hits the water at 2 seconds. Okay. Changing 18 to standard form. All I'm doing is multiplying everything out. So I'm multiplying out 2 times x plus 3 times x plus 3 minus 1. So I have 2 times x squared plus 3x plus 3x plus 9 minus 1. So I end up with 2x squared plus 6x plus 18 minus 1. 2x squared plus 6x plus 17. There's my standard form. So I just had to multiply everything out. Combined terms. All right, number 19, I'm just going to give you the equation. The first one is quadratic, the second one is linear. Y equals 0.03 x squared plus 0.88x plus 65.93. And the second one is y equals 1.92x plus 80.68. Okay. If you want bonus points on your test, explain to me why. I should have put it somewhere in the middle. I gotta stop waiting till the end. Explain why pre-AP geometry is for you. How about a tweet? So that means it has to be however many characters. If it's too many characters, I'm not giving you extra points. How about that? Ha.